Welcome to Do the Math America. I am Charlene, the Math Shaman.
Solving one-step equations is covered in the beginning algebra book on pages 107 through 110. Please use the link in the description box below this video for the PDF file of this textbook, which you may use to print out a hard copy. Solving one-step equations. An algebraic equation is a statement by placing an equal sign between two expressions. For example, x plus 5 equals 9 is an equation. 2y minus 3 equals 7 is an equation. And a number which is substituted for or plugged into the variable makes an equation a true statement. It is called a solution of the equation. X equal 4 is a solution to the equation x plus 5 equal 9. Because when you plug the number 4 into the equation x plus 5 equal 9, you get a true statement. 4 plus 5 does equal 9. Y equal 5 is a solution to the equation 2y minus 3 equals 7. Because when you substitute the number 5 for y in the equation, 2 times 5 minus 3 does equal 7, because 2 times 5 equals 10, minus 3 equals 7. To find the solution of an equation, we transfer the given equation into a simpler and equivalent equation that has the same solution. The last statement of the given equation after we transfer it should isolate the variable to one side of the equation in the form variable equal a number or a number equal variable. To check a solution of an equation, we substitute the solution for the variable in the equation to see if we get a true statement. Example number 1. Solve x minus 5 equal 9. To solve this equation, we need to isolate x on one side of the equation. So we will add 5 to the left-hand side of the equation, and whatever we would do to the left-hand side of the equation, we must also do to the right-hand side of the equation to keep the equation balanced. On the left-hand side of the equation, minus 5 plus 5 equals 0. So now we have x plus 0 on the left-hand side of the equation, and on the right-hand side of the equation, we have 9 plus 5 equals 14. So we have x equal 14. Now to double check the solution, we plug in 14 to the original equation, x minus 5 equal 9. We have 14 minus 5 equal 9. And yes, 14 minus 5 does equal 9. The solution is correct. Example 2. Solve x plus 5 equal 9. Once again, we need to isolate the variable x by itself on one side of the equation, and we do so by subtracting 5 on the left-hand side, and whatever we do on the left-hand side, we must also do on the right-hand side in order to keep the equation balanced. So on the left-hand side, we have x plus 5 minus 5, or x plus 0, and on the right-hand side we have 9 minus 5, which equal 4. So x equals 4. To check the solution, x equal 4, we plug in 4 for x back into the original equation, x plus 5 equal 9. 4 plus 5 does equal 9, so the solution is correct. Example 3. Solve 5x equal 40. In this case, in order to isolate x by itself on the left-hand side of the equation, we must divide by 5. Since 5x is 5 times x, we must do the opposite function, division, in order to isolate x by itself. So on the left-hand side of the equation, we have 5x divided by 5, And whatever we do on the left-hand side of the equation, we must balance by doing the same on the right-hand side of the equation. So we have 40 over 5, or 40 divided by 5. On the left-hand side, 5 over 5 is 1, so now we have 1x, or x by itself. And on the right-hand side, we have 40 divided by 5, which equals 8. So x equals 8, and we double check the answer by plugging 8 back into the original equation, 5x equals 40. So does 5 times 8 equals 40? 5 times 8 does equal 40, so x equals 8 is the correct answer. Example 4. Solve x over 5 equals 40. The left-hand side of the equation, x over 5, is x divided by 5. So we need to perform the inverse operation, which would be multiplication. So we need to multiply the left-hand side of the equation by 5 in order to isolate the variable x by itself. And whatever we do to the left-hand side of the equation, we must balance by doing the same thing to the right-hand side of the equation. So we will multiply 40 by 5 as well. The left-hand side of the equation, the 5's cancel out, so we have x times 1, or x by itself. On the right-hand side of the equation, we must solve 40 times 5. I do that calculation on the side. 40 times 5 equals 200. So x equals 200, and we double check the answer by plugging 200 back into the original equation, x over 5 equals 40. Does 200 over 5 equal 40? Or does 200 divided by 5 equal 40? And I do that calculation on the side, and I find that yes, 200 divided by 5 indeed equals 40. So x equal 200 is the correct answer. Example 5. Solve. Negative 12 equals negative 3 plus x. To isolate the variable x on the right-hand side of the equation, we must add 3. And whatever we do to the right-hand side of the equation, we must balance by doing the same to the left-hand side of the equation. So on the left-hand side, we have negative 12 plus 3, which equals negative 9. The right-hand side, negative 3 plus 3 cancels out to 0, so we have x by itself. We plug the solution, negative 9, back into the original equation to check if it's correct. Negative 3 plus negative 9 does equal negative 12. The answer is correct. Example 6. Solve 15 equals 3 minus y. I will start by adding y on both sides of the equation so that I get a positive y. So on the right-hand side, 3 minus y plus y, and then on the left-hand side, 15 plus y to balance out the equation. On the right-hand side, the y's cancel, and I have 3 by itself. To get y by itself on the left-hand side of the equation now, I need to subtract 15 on both sides of the equation. 15 minus 15 is 0 on the left-hand side, so it leaves y by itself, and on the right-hand side, 3 minus 15 equals negative 12. Now we plug the solution, negative 12, back into the original equation. 15 equals 3 minus negative 12. When subtracting integers, you need to add the opposite. So 3 minus negative 12 becomes 3 plus positive 12, which does equal 15. The solution is correct. Example 7. Solve 24 equals negative 8a. To isolate the variable a by itself, we need to divide both sides of the equation with negative 8. So on the left-hand side, we have 24 divided by negative 8, and the right-hand side, we have negative 8a divided by negative 8. the left-hand side, 24 divided by -8 equals -3, and the right-hand side, -8 divided by -8 is 1 times a, so we have a by itself. Now we evaluate if -3 is the correct answer by going back into the original equation. 24 equals -8 times -3, and yes, it does. Example 8. Solve -24 equals 3/5 times n. To isolate the variable n by itself, we must multiply by the reciprocal 5/3. And whatever we do on one side of the equation, we must do on the other side. So now we have -24 times 5/3 equals 3/5 n times 5/3. On the right-hand side of the equation, 5/3 times 3/5 equals 1, and they cancel out, leaving n by itself. On the left-hand side of the equation, we must now do the multiplication. 5 times -24 divided by 3. I start by simplifying. -24 divided by 3 equals -8, leaving -8 in the numerator to multiply with 5. So now I have 5 times -8 on the left-hand side of the equation, and on the right-hand side we have n by itself. 5 times -8 equals -40. So now we have -40 equals n. And we double check the answer by plugging -40 back into the original equation. -24 equals 3/5 times -40. I start by simplifying. 5 goes into -40 -8 times, which leaves -8 in the numerator to multiply with 3. -8 times 3 does equal -24. The answer is correct. Example 9. Solve m plus 2.5 equals -3.8. To isolate the variable m by itself, we need to subtract 2.5. And whatever we do on one side of the equation, we must balance by doing the same on the other side of the equation. So on the right-hand side, we have -3.8 minus 2.5. On the left-hand side, 2.5 minus 2.5 equals 0, so we have m by itself. And on the right-hand side, we have -3.8 minus 2.5. Whenever we subtract real numbers, we must add the opposite. So now we have -3.8 plus -2.5. Now we are adding decimals with the same sign. So we add 3.8 plus 2.5, and we keep the negative sign in the solution. 3.8 plus 2.5, I do that calculation on the side, lining up the decimals, starting on the right column. 8 plus 5 equals 13, write down the 3, carry the 1. 1 plus 3 plus 2 equals 6. So m equals -6.3. Now I double check the answer by plugging in -6.3 back into the original equation. M plus 2.5 equals -3.8. So I plug in -6.3 for m, plus 2.5 equals -3.8. And I do that calculation on the side. -6.3 plus 2.5. Since we are adding decimals in which the signs are different, we treat it as a subtraction problem. The bigger number gives the sign. The difference between 6.3 and 2.5 will be a negative number, and the answer is 3.8, or -3.8, which means the solution, m equals -6.3, is correct. Example 10. Solve y minus 4.5 equals negative 2.5. I rewrite this problem on the next line, giving plenty of space between characters and numbers in order to make room to write out the operations. To isolate y by itself, we must add 4.5. And whatever we do on one side of the equation, we balance by doing the same on the other side of the equation. So on the left-hand side, we have y by itself, and on the right-hand side, we have minus 2.5 plus 4.5. Now we need to do the subtraction. 4.5 minus 2.5 equals 2.0. So y equals 2.0. And I double check that answer by plugging 2.0 back into the original problem. Y minus 4.5 equals negative 2.5, and that will be rewritten as 2.0 minus 4.5 equals negative 2.5. So does 2.0 minus 4.5 equal negative 2.5? And the answer is yes. So y equals 2.0 is the correct solution. Example 11. Solve x minus 4/5 equals 2 1/5. I rewrite this equation on the next line, giving plenty of space for characters and variables so that I can include operations as needed. But first, I will convert the mixed number 2 1/5 into an improper fraction by multiplying the denominator 5 times the whole number 2 plus 1 numerator, which leaves me with 11/5 on the right-hand side of the equation. Now I will add 4/5 to both sides of the equation in order to isolate x on the left-hand side. So now I have x by itself on the left-hand side of the equation, and 11/5 plus 4/5, which equals 15/5, which can be thought of as 15 divided by 5, or 3. So x equals 3, and now I will check that solution against the original equation by substituting 3 for x minus 4/5 equal 2 1/5. So does 3 minus 4/5 equal 2 1/5? I convert 3 to 2 5/5. Now I subtract 4/5 from that, and I do get 2 1/5. So the solution, x equals 3, is the correct one. Example 12. Solve x plus 1 3/4 equals 2/5. Rewrite the problem on the next line, giving myself plenty of space to do work. And first I convert the mixed number 1 3/4 into an improper fraction. The denominator 4 times 1, the whole number, plus 3, the numerator, gives 7/4. Now I subtract both sides of the equation with 7/4. On the left-hand side, that leaves x by itself, and the right-hand side, I have 2/5 minus 7/4. I subtract these fractions by converting each into an equivalent fraction with 20 as the denominator. So 2/5 becomes 8/20, and 7/4 becomes 35/20. 8/20 minus 35/20 will result in a fraction in which the denominator is 20. The numerator will be the result of 8 minus 35. So I can think of that as 35 minus 8 with a negative sign in front of the result, which is negative 27. So the answer is the improper fraction, negative 27/20. Now I double check this solution by plugging in negative 27/20 into the original equation, x plus 1 3/4 equal 2/5. So does negative 27/20 plus 1 3/4 equal 2/5? And I write that equation out on the side. Negative 27 over 20 plus 1 3/4. Does that equal 2/5? So I convert 1 3/4 into the improper fraction, 7/4, and I do that addition. So I convert 7/4 into an equivalent fraction with 20 in the denominator by multiplying the numerator and denominator by 5, which gives me the improper fraction 35 over 20. So now I have negative 27 over 20 plus 35 over 20. Does that equal 2/5? Negative 27 over 20 plus 35 over 20 will give a fraction with 20 in the denominator, and the numerator will be the result of negative 27 plus 35, which is 8. 8/20 does simplify into a fraction of 2/5. So now I know that the solution, x equals negative 27 over 20, is correct. And now I just need to convert that improper fraction into a mixed number by dividing 27 divided by 20, which gives me 1 7/20. So the answer is negative 1 7/20. Example 13. Solve 3/7 x equals 5/7. I rewrite this problem on the next line, leaving space to do work. And first I multiply the left-hand side of the equation with the reciprocal 7/3. And whatever I do to the left-hand side, I must also do to the right-hand side of the equation. So I multiply the right-hand side also with 7/3. On the left-hand side, the reciprocals cancel out to leave 1 times x, or x by itself. And on the right-hand side of the equation, the 7 from the numerator cancels with the 7 in the denominator, leaving 5/3. So x equals 5/3, and I double check that answer, plug in 5/3 into the original equation, and substitute for x. So 3/7 times x, or 5/3, does that equal 5/7? And I see that the 3 in the numerator cancels with the 3 in the denominator, which does indeed leave me with 5/7 on the left-hand side of the equation. So x equals 5/3 is the correct answer. I need to convert the improper fraction 5/3 into a mixed number by dividing 3 into 5. So 5 divided by 3 equals 1 2/3. So then the solution is x equals 5/3, which equals 1 2/3. Final example, solve negative 5y over 7 equals 1/2. Negative 5y over 7 can be rewritten as negative 5/7 times y equals 1/2. Now I isolate y on the left-hand side of the equation by multiplying by the reciprocal of negative 5/7, which is negative 7/5. And whatever I do on one side of the equation, I must balance by doing the same on the right-hand side of the equation. On the left-hand side, the reciprocals cancel, leaving y by itself. And on the right-hand side of the equation, I have 1/2 times negative 7/5. And I multiply the numerator across to get negative 7, and the denominators multiply across to give 10. So y equals negative 7/10. Now I check that answer, negative 7/10, by plugging it back into the original equation, negative 5/7 y equals 1/2. I substitute negative 7/10 for y. So now I have negative 5/7 times negative 7/10. Does that equal 1/2? And I see that the 7's in the numerator and denominator cancel out, and 5 goes into 10 2 times, which leaves 1 in the numerator and 2 in the denominator. So on the left-hand side of the equation, I now have 1/2. And the negative signs multiply to give a positive number, which leaves 1/2 on the left and 1/2 on the right. The solution y equals negative 7/10 is correct. Practice problems for this lesson can be found on pages 109 and 110. Please do as many problems as you need to get a firm grasp of the material, and please check your answers with those in the back of the book on page 301 to make sure you do the problems correctly.
I hope you found this video helpful. Thank you for joining me at Do the Math America.